this and maybe preparing in the future for a mission to the moon or to Mars, what kinds of things does the whole team have to do in order to prepare to launch a rocket?
So, Diana, that is such a great question because, I mean, sometimes I think it does get overlooked what all goes into making a moment like this happen. So, Gary, what has the team there in Mission Control been doing to prepare for this historic launch?
Thanks, Tahira. And Diana, that's a fantastic question. Really, the operations here are not just starting today. There's been a lot of training and a lot of simulations that have been going into preparing for this moment. Really preparing and getting everyone familiarized with every step of the mission, from launch all the way through docking, and throwing different scenarios at them just in case something were to happen. Every flight controller you see behind you will be prepared to respond effectively. Now, I do want to make a shout out that it's not just the flight controllers here in Mission. But now let's head over to Hawthorne for the latest status on the crew and on Dragon. Dan.
All right, thank you, Gary. As you can see, Bob and Doug in a little bit different position now. Their suits have been rotated to the launch position. So this just puts...
Hello, everyone. Hopefully you can hear me. Let's unshare this. Ooh.
Hiya.
Hi, Roger. Can you hear me okay?
I can see you fine and hear you good.
Excellent.
I had a sneaky hearing of the launch sequence CD.
I've been watching it.
Yeah. That's
Only
right.
slightly addicted.
Hmm.
Have you been watching it?
Pardon?
Have you been watching it?
Not yet.
Okay.
The picture you can see behind me is what I took last couple of nights back.
Ooh.
North
Okay.
American Nebula. I've been out most nights with all these clear skies to capture all these images. And of course, I'm doing a talk next month for the Bath astronomers.
Yes, indeed. So this is all prep. Excellent.
I'm getting more and more images since I was initially asked to do this talk, and I might be using some of the more newer images.
So how many hours of subs are you gathering overnight then?
Well, I usually put it on from about 11 o'clock at night, and it goes through to about 3, 4 o'clock when it's too light to do any more. So I just sort of leave it running from about midnight, and then come back in the morning to switch it all off.
Ah, cool.
Yeah. So I've been doing the Sadir region, the North American Neb. I've done the Eastern Veil, the Western Veil. I tried to do the Crescent Nebula last night. It's not too good because it was getting a little bit misty where it was. So
There's been quite a bit of high cloud over the last week or so.
Yeah. Well, I've been observing Venus. That's been getting slimmer and slimmer, and that's been quite interesting.
Are you still? Did you manage to get it today?
Not yet.
Okay. I've been doing it in the day.
Yeah, I have been doing it late in the afternoon when it's still quite high up.
Yeah, because it's as soon as it gets down to about 15 degrees, it just goes into mush.
Yeah. I did treat myself to an atmospheric dispersion corrector just to help things along, and it's quite interesting to use one of those.
Oh, it'd be quite good in the mornings for things like Jupiter and Saturn.
Yeah, that would be good. But
Yeah.
I'm a night owl, not a morning person. But there we go. I'm only up there if my wife needs to get up, and I go down to check see what's going on. Then I might go out and do a bit. But
She hasn't divorced you yet, so it can't be that bad.
No, she's fine about all this. She finds it quite interesting to see the pictures. I thought, oh, that's pretty, that's nice. What's that? So she gets a bit of interest in it. So that's nice to have.
Just bear with me. I've just got to get a call.
Okay.
Hi, Sam Holbeek speaking.
Hi, it's Elizabeth Pearson.
Hello, how are you doing?
I'm doing fine. I'm just trying to sign on to Zoom, but it's asking me for a password, and I didn't get the one earlier.
Okay, should be part of the link, but that's okay. It's Ingenuity, capital INGENUITY, the helicopter on Perseverance.
Oh, God, you're going to have to spell that again.
Capital I, N, that's lowercase n, GENUITY. Oh, Annie G. It's not you, is it? Yes, I can see you. Okay. All right, thanks. Bye. I'm back again.
There you go. Yes.
Hey.
Right.
My knight in shining armor. That's what I do. How you doing, Ezzy?
Doing very well, thank you.
Well, welcome to Bath Astronomers. A small little group, but we do like our astronomy.
Mm-hmm.
And sorry for you missing the build-up for SpaceX.
Oh, I'm sure I can catch up with it later. It'll just be two blokes sitting on a sofa for a while.
It's 2 hours of two blokes sitting on a sofa. Yeah. And
yeah,
I think
people say the same three things over and over again.
The chance of the launch has dropped from 60% down to 40% due to weather. So
yeah, it's been going up and down all week, so we'll see how it's going. Is that lighting okay? Well, I'm probably going to have my presentation up most of the time.
What I'll do is I will just promote you so you can actually do presenting.
Mm-hmm.
You have now been promoted.
Hey.
So you should have the option to share your screen now.
Yes. Right. Now I just need to see if how I work this out so it shows the correct screen. I think I want to actually share. Oh, hang on. If I do that and then I share that one, and then okay,
a lovely island.
Okay, that's showing the presenter display, isn't it?
That's your presentation notes. Well,
yes.
That's
there we go.
That's the slides. Yeah.
Cool. Is there a way that I can flip between so I can see there? I can see both of you now. Cool. So yeah, I have no clock. There's one there. Cool. So I'm good to go when you guys are.
Okay. Cool. I'll just stop the sharing there. If that's okay.
Mm-hmm. That's fine.
Oh, I can see top of the half of Dennis's face. Hi, Dennis. And we're going to teach you about your microphone. You got to switch your microphone on.
I'll be back in 2 seconds. I'm just going to close the blind.
Okay.
There you go.
Again, I seem to be shown as the owner, Simon.
You're always shown as the owner, aren't you?
Yeah, why is that?
Well, it keeps coming through as the owner, so it must be on your machine.
Okay. Thank you.
How you doing, Jonathan? How you doing, Chris?
Fine, thank you.
Yeah, all good. All good, thank you. Yeah.
Excellent. We've got Jim being quiet. That's because he, oh, no video. That he's still in his lycra from his cycling.
Hello, this is Annie G. Can anybody hear me?
We can.
Yeah.
Yep.
Oh yes, I'm so sorry. I can't be seen because I'm eating my dinner and it's a bit rude. So, but I am here and I'm not a lunatic. So that's okay.
It helps being a lunatic with us.
Oh, that's all right then. I am a lunatic.
Yeah.
Anyway,
Well,
that's why I'm anonymous because I'm eating my dinner.
Lots of people. Well, we're out all night, so I suppose, and watching the moon. So that might class us as lunatics quite officially.
Yeah, because it's an exciting night. Yeah.
Oh, it is. Yes, 2 hours to go, or 2 hours 10 minutes to go before the launch.
Yeah.
And
we'll be out having a look.
And then potentially, if it does launch, then it'll be coming over the UK.
Yes. And the space station is going over too, is it not, apparently, or something?
It is very regularly. It's going to be quite hard to see, though. Lots of people are touting it, but it goes over at 9:20. That's only shortly after the sun's gone down.
Okay.
So actually spotting it's going to be quite tough.
I'm going to try. I'm not very good at seeing things. I spend a lot of time, with the showers of whatever. What are they? Showers that go over? Anyway, I never see any damn thing. I think, well, where are these bloody things? But anyway,
meteor showers and things. Yeah.
Yeah. I can never see anything. I'm not blind, but it's just hopeless. Never mind.
Well, one of the things is lots of people, they're all hyped up about how good they're going to be.
Yes.
And so if you go along sort of knowing that you might see 2 or 3, then that's hopefully going to set people's expectations rather than the hundreds that they sometimes talk about in newspaper articles.
Okay, I should bear that in mind. Anyway, I'm going back to eat my dinner, and very nice to talk to you. What's your name?
Simon.
Simon. Hello, Simon. Yes, I'm Annie, and my husband Andy's sitting next to me as well. But yeah, very nice to talk to you. Anyway, we are listening. We're just eating our dinner.
Okay, thank you for
saying it. Thanks.
Well, I'm drinking my wine.
But it's white.
Well done on the wine front. Good job.
It's champagne. It was our wedding anniversary last night.
Oh, wow. So what did you do to be your romantic self?
We shared romantic dinner. I cooked course 1, Julie cooked course 2, I cooked course 3. And halfway through, number 3 son's girlfriend delivered a bottle of champagne from her and her mum, which is now being cooled down and is being consumed today. So it's a sort of a 2-day anniversary.
Wow.
And you can guess the number of years you like.
Well, is it going to be tougher than the astronomy quiz from last week?
That's a trick question, I think, Charles.
It could be. It could be.
Yeah.
I guess 41.
Say it?
41?
Not that many. It's 4 whole beaches.
What it's anything.
Okay.
Does it have anything to do with the number of moons of Jupiter?
It has something to do with the number of planets that the solar system used to have until about 5 years ago.
Okay.
But not much, because you had to multiply by something else. Tricky one, huh?
We don't normally let you out, do we, Charles?
No, I know. 36.
Have you been exercising that Orion telescope on these clear nights?
I have. And I had a look at Mercury and Venus a few days ago. And I got some reasonable, actually, pictures of the 2-day moon, 2 days ago. As it set, I have a decent western horizon here. And of course, the moon is as thin as saliva, or was then, as Venus is now. That's quite good fun. And watching them all appearing on the western horizon is good. So, but otherwise, it's not been that good because my sense is that the transparency of the sky hasn't been that good. It's been fairly clear, but only fairly clear. And that combined with obviously the very short period of astronomical darkness means it hasn't been that good for deep sky stuff. I'm not quite sure what you think, but
So you're not one of these people touting that the lack of contrails has made it an amazing viewing time.
It hasn't been here. I mean, maybe true in theory, but the trouble is, if there is a layer of high cloud around, and it's been curious. I don't know if you noticed that during even these quite blue sunny days, if you look around, around the sun, close to the sun, you can often see some high cloud that's invisible elsewhere. And you either think, there's some cloud obscuring the sun, or you think, there's actually some cloud up there, which you only see when it's quite close to the sun in terms of lines of sight. So I think for transparency, I haven't been that impressed. But obviously, the various conjunctions you've had with Venus and the Moon and Mercury, it'd be nice to they're fun to see.
Well, can you see Roger's video and his image behind him?
This is a blank look. Sorry, I can see Roger. Yes, I can.
Yeah.
Hi. Yes, I can see. It's a video. It looks like it's still to me.
That's one of his latest pictures, despite the seeing you're reporting.
Okay.
Yeah.
That's the North American Nebula, I guess, isn't it? Looks like it. Yeah. Well, just shows what you can do with auto imaging, penetrating cloud.
Excellent. So we've hit 7:30. So what we'll do is a kick off. Chris, I've made you co-host. So if you spot anyone in the waiting area and I haven't seen them, could you let them in? Thank you very much. Okay. So hopefully you can see my screen.
Yeah.
Okay. And
free. That's good.
Okay. So the usual, I will one day stop displaying these pictures of the people that help run Bath Astronomers. But if you do stop and see them in the streets, stay 2 meters away, social distancing, but stop and have a chat. But yes, we've got Dennis, Chris, Jonathan, Abby, and myself. So the more the merrier. If you want to help out, if you can help these guys run the society, then please do. But it's not just myself, it's all these guys pulling together. So what have we got planned for this session? Well, you might notice that Demo 2, which is the SpaceX launch of the first 2 astronauts in 9 years to leave American soil, is currently underway on another channel. So those that have got 2 computers might be doubling up and watching that. So there's some exciting stuff going on. A little bit of what's up, what we're planning to do, or what's potentially around in June. We've got very lucky to have Dr. Ezzy Pearson talking to us about Rovers and Landers, sorry. So I'll introduce her a little later, but let's kick off. So there it is. This is a picture from about an hour and a half ago of the Crew Dragon sitting on top of the Falcon 9 rocket on pad 39A, the same one that Apollo 11 lifted off. It's unfueled at this point, didn't have any astronauts, but now the astronauts are aboard and they're just sitting around for a couple of hours, and they'll be launching at 9:33 this evening, subject to weather. There's lots of, there's a tropical storm around, and one of the biggest worries is for lightning. So we'll just have to see whether it's actually going to launch tonight. But, fingers crossed it will. Very exciting. New rocket, and it's a commercial one. So where people have told their children, their grandchildren that one day you can go to space, this is sort of the best opportunity for a larger number of people to get into space. Is through these kind of channels. So it's a very exciting sort of way of moving forward. So good luck to Bob and Doug, and good luck to SpaceX. I've been going into schools for the last 2 years or so, showing this demo of what's going to happen and how they potentially can be going up into space. And it's kind of an odd feeling that actually having shown this to probably what's about 600 or 700 school children, it's actually happening today. And they did arrive in the Tesla cars just as they did in the prep. So this is all underway, and fingers crossed it all goes well. So if it does launch at 9:33, one of the things you'll be able to see is that it's going to come over the UK. So the sun's going to go down just after 9 o'clock, and by 9:52, potentially becoming within our range. It's really not going to get bright enough until it's going back past the moon. So at 9:54, pretty much precisely, if you look up and about 5 or 6 moon widths to the right-hand side of the moon, just stare at 9:54, and that's your best chance for picking it up as it's rising up. And it'll go not quite overhead, but pretty well. So if you can pick it up at the moon, you'll probably be able to track it overhead and through Buetes and down the other side as well. So that'd be great. And so you're actually seeing their spaceship with the two of them in. There is an ISS pass on a pretty similar track, which starts at 9:20, but that's only just after the sun's gone down. So you're going to be quite lucky to see that. And that will be to the left-hand side of the moon, a bit further away from the moon. But if you go to a site called Heavens Above, it'll show the track for 9:20 as well. When you go into Heavens Above, there's a button for when you select a day saying, do you want to see the ones that are visible or do you want to see the ones that are all? Because it's going to be so, the sun's going to still be up effectively, also it's still going to be in twilight and hard to see, then you have to click the see all passes, because the 9:20 one by Heavens Above is considered to be very difficult, if impossible to see. It's very difficult, it's not impossible, but good luck if you go for the 9:20. But you should be good for seeing, subject to the launch, the Demo 2, the Crew Dragon, going past the moon about 9:54. I've spent quite a bit of time in the last few months just doing, a number of people have been observing Venus. Here's my shots of Venus all the way through. I actually stopped about 2 days ago because it's getting so close to the sun now. With the rig I've got, it's very difficult to do and make sure not too much sunlight's going down into my telescope. So this is as far as I get, but it'll be going into inferior conjunction just in front of the sun at the beginning of June. And then by second and third week of June, we should be able to see it coming out the other side. So you'll see the crescents the other way around. And it'll be getting further and further away from the sun. So that'd be quite nice. So we've got that on the 3rd of June, and it'll then start becoming a morning star over the weeks. But we've still got the evening star of Mercury, which is getting better all the time, and improves to the 4th of June. So just after the sun's gone down, you can see it now, but also just after 9 o'clock, but that will improve up to about the 4th of June. And then it'll, as with Venus, it'll quickly dive back down in. So it'll move through dichotomy into a crescent again. Venus has been around for very months. Mercury's got a much shorter orbit, so it's not going to be around for so much time. And the one thing to really look out for in June in terms of events is on the 19th, the moon is going to pass in front of Venus. So you'll see it occult Venus. Venus will disappear at about 8:40 in the morning. So you'll be able to watch that as it comes along, and slowly the moon will eat up Venus. And then I can't remember, I think it's about 50 minutes later, you'll see it coming out the other side. Be quite hard to pick up on the other side until it's actually out. So it's a bit of a challenge to see if you can work out exactly where it's going to come out, because that's the shadow side of the moon it's going to come out of. So you have to have the timing right and have a pretty good guess if you're using a telescope to try and work out, to see it slowly coming out from that side of the moon. But good luck. And what else have we got to see? We've got Comet Swan, which sort of kind of a bit hyped again, in that it's slowed its brightening again. It's moving away from the sun. But if you look between Perseus and Auriga, it's this week, the end of this week, it's at its highest it's going to be. So now's the time to get out and look to the northwestern skies through the north And if you've got a really good northern horizon and you haven't got light pollution in that direction, you've got a chance of seeing it, but you're fighting against the glare of the sun, which is not that far below the horizon. But good luck, have a go at it. The tail is pointed pretty much vertically. So you, especially with a camera, you've got a chance of catching it. So about a week or so ago, Andy Burns from Wilts managed to capture it. It is possible. It should have improved significantly since then. So why not have a go? And we've had Jupiter, Saturn and Mars. They've been around in the morning sky for a lot, but not many of us are early birds. We're more night owls. So they're doing a good service. They're moving into the midnight to late evening sky. And so as June goes on, it'll be more accessible to get those, and they'll be rising higher. So anyone who wants to take some images of them, then you'll get better quality going forward. And in that same patch of sky, Neptune's coming out of the glow of the sun, so you should be able to pick up Neptune as well. So they've been missing from our lives for a while, so you can get back to see them now. And because the sun doesn't go very low below the horizon, the one benefit you get from it is that it means the ISS is illuminated on more passes. So of an evening, you can have 3 passes and sometimes even 4 passes, 2 in the evening, 2 in the morning, depending on the specific day. So look out for those. Again, heavensabove.com is the site to go to check those out. But if you want to do actually see the ISS for the first time, or perhaps take some photos, then it's a good opportunity. Some people have actually taken all 4 images of a night and laid them together to show the different orbits that actually you get to see as the night goes on. And we've got the noctilucent cloud season is now underway. We've had a few reports of people seeing them. So these are about an hour and a half to 2 hours after sunset, and the same before sunrise, looking to the northwest or the northeast and seeing sort of an electric blue cloud, quite low, about 20 degrees above the northern horizon. And you know that because of that color, there's nothing else at that time. Sun's gone down by about an hour and a half, 2 hours, and you'll see the bright blue clouds, electric blue clouds, usually quite well defined with ripples. And so those are noctilucents. And we've also got, as it goes on, just on space programs, the rover, the sibling of the Curiosity rover that's on Mars, Perseverance, is completing its final tests before it's going to be stacked on a rocket in July. And it's got its little helicopter, which is going with it, Ingenuity. So final preparations in June. There'll be lots of photo shoots and things like that of it being all parceled up and ready to go. So there's a number of things that are going to keep us entertained in June. And one of the reasons why I mentioned Roger's photos, he's doing loads of photos because in June he's going to give us a talk, because he's actually been doing astrophotography for quite a short period of time, just over a year or so. And it's sort of his journey through and sort of tips and tricks, what he's done, what he's learned. And so that'll be a good journey sort of for everyone to see how in some ways easy and in some ways difficult it is to do. But when you look at the kit he uses, you think, oh, actually, perhaps I could have a go at that. So that's a good one to come along to. And then we'll have our summer break. And we've got, when we come back, Mark Radici and Stephen Tonkin giving us talks in September and October. At the moment, they're probably, I don't know, they might be socially distanced on Zoom, or we might have to find a big hall. Probably wouldn't be in the museum by then in terms of sitting people close together, but you never know. And we've got loads of stuff still going on in terms of things you can go and see. So there's the National Space Centre's running lots of sessions online. We've got the Virtual Astronomy Club. SPA has also started doing stuff. It did one on the Sun this Saturday, and BAA is publicising or doing all its webinars as well. So there's loads and loads of things to do. The BAA one clashes with us, but they always put their stuff on YouTube. So you can always catch up with what's happened on the BAA Zoom sessions there. So who have I invited? I've invited Dr. Elizabeth Pearson, who's, well, that's her full name, Ezzy, I think you prefer?
Yes, Ezzy.
Yes. And where might you have seen her work? Well, if you got one of these magazines, then if you just turn to the news page, there you see, up in the top, that's where you probably read her articles many, many times over the years if you get the Sky at Night magazine, which I do. And so someone's curated all of that, someone's a wordsmith, someone's brought it all together, made it work. One of the things I have to thank you for, Ezzy, is I try and keep on all the news feeds and so. And when I read this, I found out I read the articles, the original articles, wrong. And you're correcting me. I didn't actually understand the science or didn't understand the importance of something. So when I read this, I go, oh no, I didn't understand that. Now I do. Excellent. So thank you for correcting me on so many occasions, silently, when no one else knows that I got it wrong the first time.
Oh, glad I can help.
You've also been busy on this one because you've got a Starlink article in this month's. So, I suggest perhaps you're not so much of a fan.
It's a complicated issue, put it that way. For anybody who doesn't know, Starlink is SpaceX's mega constellation, which is their plans to put up something like 12,000 satellites into space, which are currently at the moment naked eye visible. So there's some issues around that, and it's all about how they're dealing with that situation.
Excellent. So if those weren't credentials enough, you do have a PhD in extragalactic astrophysics. And I have no idea what that would mean. What on earth do you study in extragalactic astrophysics?
I have a PhD in measuring how far away, very far away things are. Is basically what my PhD is in.
We have a member called, actually on a committee, Abby Chown. She has been measuring Cepheid variables in the Large Magellanic Cloud, and just to make sure the start of the baseline is correct. So potentially the longer baseline stuff can be made more accurate.
Yeah, this was kind of stuff that's as far away as you can get without hitting the CMB, pretty much.
Excellent.
But yeah.
Okay, well, thank you very much. I will allow you to take over control, hopefully. And so, Ezzy, thank you very much. Tell us a little bit of a brief history, because it's been about 60 years or so of landers and rovers firing at planets and things. So tell us more about it.
So yes, as you just said, I have a fascination with planetary exploration and planetary science. I think it's absolutely fascinating. And I find it quite funny that I'm giving this talk today when they're preparing to do the first human launch from American soil in 9 years. Because I've always thought that the human side of space exploration kind of overshadows the robotic side. And that's why I really love researching about all of the different rovers and landers. It actually led me to write a book about it called Robots in Space, which will be out in October. Plug, plug, plug. And this is basically me over the next 45 minutes to an hour trying to cram as much as I can of the last 60 years of planetary exploration into this talk. So we'll see how I go. I'm sorry if I leave out your favorite spacecraft. I don't have time to fit them all in. However, I do know a lot of information about a lot of things, so do feel free to ask me any questions at the end. So yes, let's get a crack on with it then. So how does exploration of planets work? Generally speaking, there is a kind of standard pattern to how we explore different worlds. I won't call them planets because it's different types. There's not just planets, there's moons and comets and asteroids as well. So the first thing that we tend to do is have a flyby mission, which, as it sounds, just shoots past, has a look out the window and goes, oh look, there's a planet there. Then move into orbit around the planet wherever possible. And once you've managed to put something into orbit, people will try and put a lander down on the surface, get to understand the surface a bit more. Once they've managed to successfully land on the surface a couple of times, space agencies tend to want to send something a bit more mobile. So they'll send a rover and then finally a human. Doesn't always follow that pattern. The moon, as we'll see, was a bit jumbled all over the place, but generally speaking, that's how things progress. So there are many different types of worlds in our solar system, and we've got to different levels on this chart with different of them. So obviously, the moon is the only place that we've had humans visit so far. Then there's rovers, which we've had Mars, rovers to
Ezzy,
Mars. Yes.
I'm not seeing your screen. It might be a problem with my Zoom.
Screen. Is anybody else not seeing my screen?
Yeah, we're screenless at the moment.
Screenless, okay.
We can
Has
see
that always
you,
been
but
the case? Has that always been
Yeah,
the case, or is that just gone? Okay, hang on. Right. Try that.
No.
oh yeah,
Oh,
something's
there we
happening.
go. There we go. All right, can you see it now?
Perfect.
Yes.
That's
Yeah,
great.
that's good.
Cool. Sorry about that. So yes. Now, hopefully, can you see both? Can you see me as well, or just the screen?
Yeah, we can see you on the little inset picture.
Cool, excellent. So yes, this is where we've got with most people. So we've had humans being sent to the moon. We've had rovers have gone to Mars, landers on comets, asteroids, Viking, and Saturn's moon Titan, and then orbiters and flybys to various other moons and planets throughout the solar system. So we will be concentrating on those last three, those middle two, landers and rovers. So as with a lot of early space exploration, the initial exploration of the world's planets had a lot to do with the space race back in the 1950s and 60s. When Sputnik launched back in 1957, not very many people really cared about space before then, but it was one of those things that a few, sci-fi nuts and space experts and scientists really cared about. But for the most part, the public, it was kind of the realms of science fiction. Then when Sputnik happened, it exploded. It became super popular. And most of that was to do with the fact that it became a political tool. It was the time of the Cold War. Both the Soviet space agencies and the American space agencies were sort of playing that fear of, if they can put a satellite into space, maybe they can drop a bomb on our heads, towards the military leaders, which helped push forward that early space race. And that was one of the reasons why things started escalating. And it became a race of firsts. So who could get the first satellite up, which was run by the Soviets? Who could get the first thing to fly by the Soviets, which was, so fly by the moon. Again, that was won by the Soviets with Luna 1. And then in 1959, they achieved the first impact on the moon as well. And that was done with this little beauty, Luna 2, which is basically a big ball covered in spikes. Those spikes are various different antennae and for transmitting backwards and forwards from Earth. There was no propulsion on it. It was basically, they shot it into space on the back of a rocket, and the rocket was what did the aiming. If the aiming on the rocket was off, they were off. The spacecraft released a big cloud of sodium so that people could track where it was, because there'd been a bit of uncertainty over whether Luna 1 had actually happened. A lot of the Americans were saying, no, they didn't send a spacecraft, they're lying. It's called the Big Red Lie. They did, but they didn't want to make that same mistake, so they sent out this nice big cloud of sodium so anybody could have a look and see that this spacecraft was impacting on the moon. And it didn't really do much science. Again, it was mostly a political tool that they rushed out as quickly as they could. And you can tell that it was a political tool because this is what it was carrying. So this is a giant steel ball with a bunch of little pennants on it, which say the year and CCCP, which was at the time the name of the Soviet Union. And these, when Luna 2 impacted against the moon, scattered all over the moon surface, and they're still up there today, letting anybody who should find that impact site know that the Soviets were the first people to get there. And it was shortly after this that things started to pick up elsewhere with plans of getting to the moon, because at this point the Soviets had won every single space, every single milestone. The Soviets had got there first. They were beating the Americans. The world was shifting from a world where America was the military superpower to the ones where the Soviets were beginning to seem technologically superior. And the Americans just couldn't let that happen. So in 1961, there was a presidential race going on in the US, and JFK came up and said, if you elect me as president, I pledge that we will go to the moon. And he put down this pledge, he threw down the gauntlet, and suddenly everything came about putting people on the moon. Not just sending robots, but sending actual people. At least in the US. So the US was still trying really, really hard to get to the moon, but they were struggling to even, launch satellites, do anything to get there. Meanwhile, the Soviets were making leaps and bounds. So in 1966, they launched Luna 9, which you can see here. And this was the first, what we call soft lander. So can you see there's that big sort of glossy bag on the top end of it? That is actually an airbag. And on the other end is a really big stick. And when that lander approached the surface of the moon, that stick hit against the surface of the lunar surface, triggering that airbag to deploy, so that it was a nice big soft cushion around Luna 9, so that when it hit the surface, it wasn't immediately vaporized, it wasn't exploded apart, it had a nice soft touchdown. It also had some retro rockets as well to help slow it down. And this was the first time that any nation had managed to soft land on the moon. And it was the first time anybody had managed to soft land on the moon. It was also the first time anybody had managed to put a camera down. And these are some of the first images that were transmitted by Luna 9 back to the Earth. And it's kind of a funny story about this. You might think in today's age, especially with NASA, the second anything happens, as you can see now with the Demo 2 going on, they're live streaming it and you giving out information about exactly what's happening. That wasn't what the Soviet Union did at all. They were very, very secretive. They didn't say that they were about to launch anything until like seconds before they were about to launch it. They didn't let out any photos that they didn't want to get out. They were very, very secretive. But these photos, possibly the most important photos of the space age up until this point, the first images from Mars, they didn't release. They were printed they were released to the world in a British newspaper, the Daily Express, because nobody had sought to encrypt them when it was being transmitted back to Earth. Jodrell Bank picked up the signal. Somebody working there recognized the type of signal as the same coding that they used to transmit newspaper pictures back and forth across the Atlantic. So they grabbed their fax machine, printed it out, and the Daily Express managed to print these photos first out ever in the world. From that point on, the Soviets encrypted their data streams. They had learned their lessons. But again, it showed, this was front page news. It was something that was considered one of the biggest scoops of the year, if not the decade, for the Daily Express to get this. So you can see that it was a big news. Meanwhile, over in NASA, they were still working out how to get people onto the moon. That was their big goal. But they realized that if they were going to get people onto the moon, they needed to scout the way first. And they did that with the Ranger and the Surveyor missions. So the idea behind Ranger was that it was going to be it was initially a scientific mission. It was put into motion long before JFK threw down his gauntlet. And the idea is that over 3 years, it would send these impactors, they would crash into the surface of the moon, taking pictures as they went, getting closer and closer and getting a really good close-up view of the Earth. Then after 3 years, the surveyors would take over. So Ranger was basically to give NASA time to build the soft landers, the surveyor landers. These are about as big as a person, by the way, to put those into perspective. And they managed to land eventually, after 7 attempts, landed Ranger in 1964. They did not have a good lot of luck with Ranger. And then 2 years later, Surveyor followed suit. And these, as I said, initially, they were supposed to be scientific missions. But as soon as the Apollo program came about, they were completely co-opted. Their scientific instruments were ripped out for ones that would better suit the Apollo missions. Their landing sites were chosen to be Apollo or potential Apollo landing sites. And they were really, it quite impacted the science that they could do in order to facilitate Apollo. And this was around the time that the US started pulling ahead of the Soviet Union in terms of human spaceflight. The Soviet Union, behind their veil of secrecies, was having a lot of problems with their space program, whereas NASA was going from strength to strength. And then eventually, in 1969, Neil Armstrong took his one small step for mankind, and they managed to get onto the moon. Then the Apollo missions kind of took over everything. And so this, I think, is from Apollo, it's got a rover in it, so I think it's Apollo 15. And this was actually the first rover that they sent to the moon in 1970. However, it wasn't the only rover, it was just the only one that was piloted by human hands. Because whilst NASA was absolutely obsessed with getting people on the moon, the Russians were carrying on their robotic exploration. They had been having their own human spaceflight program. They never officially announced that they had a human spaceflight program, but they were trying to send people to the moon. They did not do terribly well, and long before 1969, they sort of threw their hands up and said, we're not going to send people, but we'll carry on trying to compete with the US in other ways. And one of the ways they did that was with the Lunar Cod rovers. And these are incredible machines. Again, this is about as tall as a person. And these were the first rovers to be sent to the moon that were completely operated from Earth. They had to be driven by hand by people on the surface. And they had to be driven using images like this with a 30-second delay. So just imagine trying to drive around on the lunar surface using that image. It was quite difficult. There was a lot of trouble going on. At the same time, the Soviets were also sending Lunar 16, 20, and 24. And these were sample return missions. So the Soviets did actually manage to bring back lunar samples from the moon using these incredibly intricate machines. Unfortunately, though, both the Lunar Cod rovers and the sample return missions by the Soviets got very overshadowed by the Apollo missions. Most people don't even know that these things got sent up, which I think is quite sad that the Soviets didn't really get their due for that, at least in history. So yes, Lunar Cod, brilliant machine. But so the Soviets weren't doing very well at the moon. So instead, they tried to focus their attention elsewhere. Because in reality, the Soviets never actually wanted to explore the moon in the first place. Where they wanted to explore was the planets. They wanted to explore Venus and Mars, but they got drawn in to this Apollo space race to go to the moon because they felt they had to. The Americans were saying, we're going to go to the moon, and they felt they had to meet that challenge. So eventually, towards the end of the 70s, everybody was falling out of love with the moon. They refocused to another area of space exploration where they've been having a lot more success. And that was Venus. So Venus has long obsessed people. It's about the same size as Earth. It's about the same mass. It's 0.7 times, it's at 0.7 AU, Earth-Sun distance from the sun, so it's a bit closer. And when you're looking at it from Earth, it does look like a fairly, if you're just looking through a telescope, you could quite easily believe that it's an Earth-shaped world. People could see that it was covered in clouds, and there was all kinds of science fiction writers imagining these lush rainforests beneath the clouds of Venus. And so it was believed to be one of the places where you're most likely to find life in the solar system beyond Earth. And it was one of the places that the Soviets really, really wanted to investigate, and they did with their incredibly successful Venera program. So this was a series of 16 successful or successful-ish missions that went to Venus. Some of them were flybys, some of them were orbiters, and some of them were landers. Some of them were also atmospheric probes, but we'll get onto that in a bit later. Now, I'm sure that most of you know that because of the way that the planets rotate around the sun, there is a window of opportunity when you can go to Venus and Mars. For Venus, I think it's once every 19 months you can launch a mission to get the shortest route to Venus without having to, go halfway around the solar system and back. Which meant that the Soviets always launched in pairs. That way, one mission might fail. The chances of two missions both failing was greatly reduced. So it was one of their ways of trying to ensure success. That said, there were still quite a few failures. And the first mission that actually succeeded in reaching Venus in working order and managing to transmit back was Venera 4, which you can see a model of here. And this was the first probe to successfully look at another planet. It was supposed to actually touch down on the surface. It had, hang on, let me go back, one of these landers on the bottom that you can see on the right here. And these were basically giant sort of like lemons suspended beneath a parachute with a bunch of instruments in, and they were designed to float down through the atmosphere, through that thick atmosphere that they thought was around Venus, and float in an ocean or land on the surface, and pretty much be able to deal with anything that they thought was on Venus. Unfortunately, they had vastly underestimated just how horrible Venus was. By the time Venera 4 rolled around, they were beginning to realize, the planetary astronomers of the world were beginning to realize that Venus was a horrible, horrible, horrible place with huge high temperatures, incredible pressure, and just a whole atmosphere that was designed to kill spacecraft and landers. So Venera 4 never reached to the surface, it was crushed. They didn't have time with the next pair, Venera 5 and Venera 6, to really fix those problems, to make them withstand the pressure. So they just kind of fired them, saw what they could see of the atmosphere, and had no expectations of getting to the surface. Venera 7 and 8, however, they consulted some a group of engineers that might help them survive this horrible pressure. And that was submarine engineers. And they taught the engineers at the Soviet Space Agency how to build these probes to withstand the extreme pressures, up to 150 atmospheres this thing would withstand. And Venera 7 was the first one to manage to touch down on the surface. Unfortunately, when it touched down, it promptly fell over, and its antenna wasn't pointing at Earth. They managed to pick up a very, very faint signal to prove that Venera 7 was there on the surface, but not that they couldn't really pick up any useful data. Venera 8 was a bit more successful. They managed to get the answer back. Then, in the next window, they sent Venera 9 and Venera 10, and that was something a bit of a step forward because they had cameras on. And this is one of the first pictures sent back from the surface of Venus from Venera 9, showing a kind of a rocky surface. And these were the first images, proper images, sent back from another world. From another planet. But of course, people always want more, always want better. And so the next time around, they sent out a machine with some color cameras on. They didn't tell the world that was, of course, because that's not the Soviet way. They didn't say that there was color cameras on, but there were. Unfortunately, what they hadn't done was they created this incredible machine that could withstand the pressure on the surface of Venus, withstand the caustic atmosphere. But what they hadn't done was check that the lens caps would come off. And so Venera 10 and Venera 11, Venera 11 and Venera 12 got to the surface of Venus, were operating in perfect order. They tried to take their picture, and all four lens caps, both lens caps on both machines, got stuck and didn't come off, and they couldn't take those color pictures, which must have been absolutely soul destroying if you've been working on this thing all your life, and then that happens to you. Fortunately, they got another chance 18, 19 months later, fixed their problems, and got these pictures in 1982, the first color pictures from the surface of Venus. And again, it showed a volcanic, highly unhospitable world, not a very nice place to visit, but they managed to get these pictures back. And it was such a horrible place that the Soviets were beginning to realize, you know what, I don't think we can do anything more useful here, not with today's current technology, not when you only get an hour or maybe even 2 hours on the surface before your spacecraft dies a crushy death. So they decided, you know what, it's time to forget the surface. Let's look at something else. Let's look at the atmosphere around Venus. Because Venus's atmosphere is incredibly interesting. It's made of mostly carbon dioxide. It's got sulfuric acid clouds, huge winds. It's the huge temperature differentials and things. And people were really interested to see this. And one of the best ways to investigate the atmosphere was to replace your probe's parachute with a balloon. And so they came up with the Vega expedition. This was in the 1980s, the Soviets were beginning to move away from their policy of extreme secrecy, extreme isolation, and they were beginning to become much more involved with the international crowd. So this started as work with the French. That sort of fell through as time went on, but the Soviets increasingly worked with a whole bunch of other different nations, Germany, Switzerland, a whole bunch of others, to create the Vega missions. And these sent their spacecraft into the atmosphere around Venus bobbed along and took a bunch of readings before eventually the balloon floated around to the day side of Venus, got incredibly hot, and exploded and dropped it. But they managed to spend quite a while up there in the atmosphere investigating what was going on. Unfortunately, it happened to be about 55 kilometers above the planet's surface, which they discovered is apparently one of the most turbulent areas of Venus. So these things got, put around in circles. They get dropped the 3 kilometers in 30 seconds and then blown back up again. But they did a good job investigating the air currents are there. And it was an awesome program. The entire Venera and Vega programs were incredible, but they've sort of been forgotten again by history because of this Soviet policy of secrecy and just not tooting their horn as much as NASA does. And that is the main body of the Vega mission before it dropped off its probe above Venus. And actually this went off and then investigated Comet Halley, which happened to be coming by at the same time. So yes, that was incredible. And as I said, this was a bit of an international mission. And part of that was done because if somebody else is building part of your spacecraft, somebody else is paying for part of your spacecraft. Because the Soviet Union was having some real financial difficulties at this point. They were having to sell off spacecraft that they weren't using to raise funds. They were having to do all sorts of things to raise money. And unfortunately, this mission probably didn't carry on as much as it could have done and possibly should have done due to other factors within the Soviet Union. But for all of their success at Venus, there was one planet where the Soviets didn't do so well, and that was at Mars. Whilst the Soviets were exploring Venus, they were also attempting to explore Mars. Now, Mars has got a bit of a reputation of being a cursed planet. 50% roughly of all missions that have attempted to land on Mars or even get to Mars have failed. And that's a lot in the part because 15 out of 18 Russian attempts completely failed, and the 3 that did vaguely succeed didn't really. But why is it so difficult to land on Mars? Well, partly that is because it's a very middling world. So Mars gains a lot of attention. It didn't initially get a lot of attention. Most of that went to Venus. But when they realized that Venus was a horrible hellhole, everybody started looking at Mars as a potential place to find life. People had seen dark areas expanding and contracting across the surface and thought that might be vegetation. Turns out it wasn't. But there still looked like there might be some sort of water on life. And generally speaking, throughout the solar system, or on Earth anyway, where you find water, you find life. And so that was why Mars had a great view. Unfortunately, it is an incredibly difficult planet to land on. And that's because of the main ways that you land on a planet. Mars is precisely lined up to be terrible at all of them. So there are 3 main ways that you slow down when you are trying to not smash into a planet's surface. The first one is that you use aerobraking, which is literally you use the planet's atmosphere to the air resistance to slow you down. You have a big heat shield to dissipate the heat, and you just try and get that to slow it down as much as possible. Unfortunately, Mars has a very thin atmosphere, which means you can't ignore it completely, but it's not enough to really slow you down to hit the surface nicely. The next is you have parachutes, again, using air resistance to slow you down. And again, Mars isn't quite got a thick enough atmosphere to slow you down entirely. Finally, when you're very close to the surface, you can use retro rockets. And these retro rockets just literally keep your things trying to levitate above the surface, take off that last little piece of velocity so you don't smash into the surface when you get there. That one doesn't need an atmosphere, the other two do. So when you're landing on something airless like the moon, you just use retro rockets, whereas the other two only work on planets with an atmosphere. And unfortunately, Mars has just enough atmosphere for it to be a problem. Its friction will make you burn up, but not enough atmosphere to actually be useful to help slow you down. So it's incredibly hard to land on it if you even get there in the first place. So the Soviets sent a bunch of missions to try and land on the surface. And the first one that vaguely succeeded was Mars 3. It managed to land on the surface. It managed to send back a signal for 14 seconds. This is what it managed to send back. Only 70 lines of code were sent back by the cameras on Mars 3, the first thing to land on Mars. There's some people who claim that this, you can see the horizon here. I don't know if you can see my pointer, but there. I think personally it's just noise, but it's nice to think that maybe somebody managed to get a horizon back in the 1970s. So yes, the Soviets weren't doing terribly well at Mars, but instead NASA decided to take up the moniker, just tried to land on Mars. And they eventually managed it with their Viking landers. So these were a pair of, there were two spacecrafts. Again, it was that principle of doubling up. If one fails, the other one will succeed. That had an orbiter that would stay in orbit and a lander that would go to the surface. And this pairing up of orbiters and landers really greatly improves the amount of science that you can do with your mission. Because with the Venera landers, mostly those were trying to transmit their data directly back to Earth, which meant you had to have a beefy enough transmitter that it could transmit all the way back up to Earth. And those are heavy, and you've got to land out weight. If instead it's transmitting up to the orbiter, it's only got to do that couple of 100 kilometers from the surface up to orbit, and then the big beefy transmitter with its big heavy battery can be on the orbiter sending it back. And so now that kind of pairing of orbiters and landers is pretty much how we do every single lander these days. The only exception really there is to the moon, because the moon's just about close enough that you can get away without one. These operated on Mars for many, many years. They did some incredible science. But the landers, which looked a little something like this, were absolutely obsessed with, or at least they were very general science machines. They were just looking at what was on the Earth, but they had on board 3 life-finding experiments. And that, of course, was what the public really picked up on, that this was Viking. It was going to try and find life on Mars. And as you know, it didn't, unfortunately. There was some debate that maybe one of the experiments might have shown signs of life, but a lot of people think that was a false positive caused by some other chemical reactions on the surface, though the PI of the experiment still argues that to this day. As I said, it did a lot of incredible science. It gave us our first really clear view of what Mars was like on the surface of this world. Unfortunately, in the public eye, it hadn't found life, and it was a failure. And that put off Mars exploration for another 20 years. People just thought, what's the point of going to Mars? It's just a barren world, it's a dead world, it's like the moon. We're not going to the moon anymore. Why should we bother going to Mars? And it took 20 years for people to get back that Mars spirit and want to go back to visit Mars. These are some of the images sent up by Viking. But I'm running out of time, so I'm going to power through them. And then in the late 90s, NASA finally managed to get the public back on board, because with NASA, they always have to have the public on board with what they do, because ultimately that's who's paying. The American taxpayer funds NASA, and those are the people you have to please. And eventually they got the taxpayers back on board and decided to send Pathfinder back to Mars. Now, originally, Pathfinder was part of a project called MESA, which was going to send 16 of these stations around the planet and create a network. Because whilst a single lander can tell you a lot about one point on the Earth, on the planet's surface, in great detail, and an orbiter can tell you something about the entire planet on a low level of detail, there's that kind of missing gap in between of knowing a lot about a much wider area. So the idea was that they were going to send a network of these stations all over Mars that would work together to do far more scientific exploration than anybody else, than a single person could. That fell through before Pathfinder even launched, unfortunately. Networks are hard to get funding for, because they require funding for, you know, a decade rather than a couple of years, which doesn't really work with the way that the American politics situation works. But it was still an incredible machine. It was the landing station would analyze the weather and the atmospheric dynamics that were going on around it, but it also had on it another little instrument, which you can see there, and that was Sojourner. So Sojourner was the first ever Martian rover. It's about 0.5 meter long. It's really quite diddy. But the idea behind this was that it was a test of how to run a rover on another planet. It was basically teaching NASA and the rest of the world, how do you operate a rover several million miles away? And this was the kind of geologist of the project. It was able to trundle around the surface, get up to rocks, have a little look. It could scratch at the surface of the rocks and get a look on the pristine surface, and use its various instruments that it had on board, which then got transmitted back to Pathfinder. Pathfinder transmitted it up to one of the orbiters in space, and then that got sent back to Earth. Now, this entire setup was only supposed to last for 7 sols, which is what you call a Martian day. It's a sol. It's about 24 hours and 37 minutes. But the two together actually lasted for 83 sols. And they found evidence that there was water on Mars in the past, that it flowed, and gave evidence that even though there wasn't life on Mars, there might have, or they couldn't say for sure there was life on Mars now, there might have been in the past. There was the evidence that it might have been habitable. Because that was what this mission was all about, trying to find water on Mars and evidence that the planet might have once been habitable. Because NASA had learned their lesson from Viking, they weren't about to say we're looking for life, or we're looking for something we might not find. This was a test run to just go and try and get to know the planet better. And there's Sojourner having a look at a big rock. I believe that might be Big Joe, which is a big rock close to one of the landers. And Sojourner was also very much learning how to land on the surface of Mars. And in fact, it was almost scaled up and copied for the next iteration of people to land, rovers to land down on Mars, and that was the Mars Exploration Rovers, better known as Spirit and Opportunity. These were as I said, basically just really scaled up, beefed up versions of Sojourner. They had massive solar panels put on them so that it could operate for a long time. They had more sophisticated geological instruments. And again, they were exploring the Martian surface, having a look at all of these rocks, trying to establish exactly how habitable Mars might have been in the past, as well as sort of general geology of the Martian surface. And these were hugely popular with the public. Partly, I think it's just because they were very sort of anthropomorphic. They looked like they've got a little face. And because they had names, Spirit and Opportunity, people started giving them personalities. And people really started getting enthusiastic about Mars exploration. So when, and people loved seeing like photos and selfies taken of these spacecraft. And that was another thing when they went on to the next Mars mission, which was Curiosity on the surface. Again, Curiosity had a huge publicity campaign behind it to really sell it to the people, because NASA knew that these rovers are incredibly charismatic. They are the way that you sell, because whilst sort of, an X-ray telescope is very exciting to, a scientist or an astronomer, to most people, they don't really care. Whereas these charismatic rovers are one of the ways that you sell space to the public. So it was also, of course, an incredible machine. This one was very much beefed up. It was incredibly heavy. They had to develop a new landing method called the sky crane, which was, they literally landed Curiosity on its wheels. It wasn't in like wrapped up in some kind of box like the previous had been. Just landed on its wheels and then trundled off across the surface of Mars. And this was much more of a kind of general all-purpose robotic scientist. It had a lab on board which could chemically analyze some of the rocks. And again, it found even more building blocks of life. So again, couldn't prove that there was life on Earth, but it was another step towards the fact that there might have been once, it might have been habitable, lots of it might have been. We'll have to have another mission so that we can go and find out and be certain. And here we go. That's another image taken by Curiosity of a lake bed. And I'm going to rush through now because I am running out of time. There have been some various static landers to Mars as well. Most of them are based on the design of this one, which is the Phoenix lander, which is actually based on the Polar lander, which crashed. And the advantage of a lander over a rover is that it can really dig in. And there's a lot of science you can't do unless you sort of hunker down and either drill into the surface or just in a very stable spot. And that's one of the things that Phoenix did. It was investigating the Northern Pole, and it found the first signs of ice on the pole of Mars. That white patch in the image is a lump of ice that was exposed by Phoenix's thrusters when it landed. And this was such a surprise. This is actually an engineering image that got taken. And the team was so surprised when they saw this, one of the first images back from their lander, that somebody said, "Holy cow, would you look at that?" And that's why this is called the Holy Cow image. Like I said, another lander that's been sent more recently, back in, when did it launch? I think it landed in 2018, the InSight lander. Again, based on that same design. NASA really like to double up on their design. If they've got a good design, why waste it? Just use it again and again and again, just put different instruments on it. That's their philosophy. And again, that could really hunker down. It could drill down, it's trying to drill down into the surface of Mars to listen to the acoustics and heat flow throughout Mars. So there's been a whole bunch of missions to Mars. All of the successful ones that landed have been from NASA. Beagle 2 did manage to touch down and unfold, but didn't quite make it all the way. And so, like, all over Mars, we've had lots and lots of various different things. And again, most of these have been about investigating past habitability and very specifically trying to find water on Mars. Because where there's water, there is life, at least on Earth. But one of the big questions that this didn't answer, these various missions discovered that yes, there was water on Mars, and there still is some. It's not liquid, but there is some water on Mars. What they didn't answer was, where did that water come from? And that's one of the big questions of solar system science. When planets form, our best knowledge of how planets form anyway, is that they should have been too hot for any liquid water to settle on the surface. It should have all boiled away. But we see liquid water, at least on Earth. So how did that happen? Where did it all come from? And that's why a lot of people have been trying to track down other sources of water in the solar system, mainly comets and asteroids. And that's why we have been sending landers and rovers and various other things to these things for a long time. Now, obviously, people originally thought that, well, comets, they're big lumps of ice. You get one of those, that's your water problem sorted on Earth. That must be water. So they went to have a look at these comets over the years. They've had missions like this, which was Stardust, which was a very, it's a sort of lovely romantic mission. It flew through the comet's tail, captured its stardust, and then brought it back to Earth for us to have a look at. And that was actually a very successful mission. I managed to have, that was the first time we sort of touched a comet's tail. The next mission, slightly less romantic, Deep Impact. Hit it with a bullet. So Deep Impact, literally as it sounds, it fired a massive weight into the surface of a comet, kicked up a huge cloud of dust and debris, and that was what, and then the spacecraft itself looked at the cloud and the debris that was kicked up, and the size. It was supposed to also look at the size of the crater as well, to tell as much about the comet as they could. And this, I won't do too many loops of this because it's a bit nauseating, was the image, that's enough of that. That was the Deep Impact lander approaching the comet, and this was the explosion that it created. So very bright flash of light. And Deep Impact, together with another space mission, really examined that comet to get to grips with it, and work out what it was made of, what density it was, and what it was like there. And then our final, or our latest, I should say, mission to a comet, you probably already know about, and that was the Rosetta mission and its lander, Philae. Philae didn't do great when it landed, as it bounced into a shadow, couldn't charge its solar panels. So whilst it did all of its main science program, it was supposed to last a lot longer. Unfortunately, it couldn't recharge its solar panel, so we only got that initial battery charge of 60 hours of science from the surface. However, what we learnt from these 3 missions is that comets almost certainly didn't bring water to Earth. It's the wrong flavour of water for Earth. Comets do seem to have a lot of other very interesting things for life. Lots of what's called organic compounds. That doesn't necessarily mean biological, it just means it's got carbon and hydrogen in it. And those are the kind of building blocks of life. And those were on comets. So a comet might have brought the building blocks of life to Earth, but what they didn't bring was the water. So now people are turning their attention to the other water sources in the solar system, and that's asteroids. Now, you might think these are big dry rocks, but actually asteroids can hold an awful lot of water. They're a lot wetter than we think they are. And we've sent various missions to asteroids. Pretty much every mission going beyond the asteroid belt has flown by an asteroid, because you might as well whilst you're on your way. Beg my pardon. But we sent 3 missions that have or will attempt to touch these asteroids. The first one was Hayabusa, which went in the early 2000s and met with some incredible bad luck. On the way to its asteroid, it was struck by a solar flare, and just it never really fully recovered. It had a horrible time. It arrived back home about 7 years late. And this mission was actually sent not by NASA, not by Europe, who sent Rosetta, and not by the Soviets. It was actually sent by Japan, who were kind of, their whole idea was, we can't compete with these other big space agencies to land on Mars or something, so let's try to do weird missions they would never think to do because they're set in their ways. And so that's why they decided to send this Hayabusa mission. And the idea of it was that it would fly towards the asteroid surface, pick up a sample, and then rather than trying to analyze it on board, like the Mars rovers do, it would bring it back to Earth and be analyzed here. Unfortunately, as I said, terrible bad luck, never quite made it properly. And so the Japanese decided to redo it. And Hayabusa 2 is currently in orbit around asteroid Ryugu. When it first got there, it dropped off a bunch of these little Minerva landers to get a nice close-up view of the surface. And in fact, this is their view of the surface. That's a close-up of an asteroid. And then they tried to get their sample, which, is this going to work? Yes. So this is Hayabusa leaving the surface, having just touched down. That GIF doesn't seem to be loading properly, never mind. But yes, so it flew in towards the surface, grabbed its sample, and then flew back again. And it is currently on its way back to Earth, hopefully with its lovely new sample of asteroid dust. NASA is also sending their own OSIRIS-REx, who announced a couple of weeks ago that they are ready for their own attempt to grab a sample off the surface of an asteroid on the 20th of October is when they're going to try and grab it. So watch that space for that one. And that one will return later next year, hopefully. And whilst we haven't really had enough of these samples, there was a little bit of asteroid dust in Hayabusa, the first Hayabusa, which was enough to begin to hint that maybe it is the right flavor of water, that maybe these asteroids did bring water to Earth. And in fact, one of the things that OSIRIS-REx found about its asteroid Bennu was it was a lot wetter than it was expecting. A lot more water on that asteroid. So perhaps they did bring water to Earth. And finally, there isn't just Earth, which has liquid water on it in the solar system. No other planet, as far as we're aware, does, but a couple of moons appear to have liquid water under their surface, such as Europa, Ganymede, Enceladus, around the gas giants Jupiter and Saturn. And there's lots of various cunning plans to try and, some of these moons, we've seen giant geysers of water shooting up through the sky. And so there's been plans to maybe have a Stardust-like mission to go fly through the geysers, collect up all of that lovely juice, and then bring it back to Earth. But there has been one landing mission which did actually manage to land on one of these moons. But that was actually the moon of Titan around Saturn. And this was the Huygens probe, a European probe that was attached to the bottom of Cassini. when it flew to Saturn back in when it flew back to Saturn. And it was designed because at the time, we thought that this moon could be home to seas not of water, but of hydrocarbons, of methane and ethane. So Huygens was actually designed to float in case it came down in a Saturnian sea. It didn't, it came down on some rocks. But it managed to transmit from the surface for a good couple of hours and give us our first view of a moon of another planet. And that's kind of one of the areas that people are really excited about for future exploration. It's not the planets themselves, it's those icy moons around Jupiter and Saturn, and that's what people are really hoping to get out there and explore. So, what's next? People are still carrying on at Mars. This summer, depending on how many actually make them to the launch pad, you've got Perseverance and Rosalind Franklin and I can't remember its name, but the Chinese one, all will be heading to the Mars surface. Except Rosalind Franklin won't be now. That's been delayed until 2022. But hopefully the other two should be making its way towards surface. But also, people are very interested in going back to the moon. We've already had China, particularly, has been making strides to get back to the moon with the U2 lander and U2-2 on the far side of the moon. And these are little rovers which have been running around the surface, really getting to know basically, they're China learning how to land. They're one of the new emerging space powers, and they've really been making strides in this arena. And they, just as the US, they want to get to the moon. They want to land people on the moon. That's their final go. And this is a step along the way, is sending a rover to investigate the surface. And then, as I said before, you've got the Perseverance rover is hoping to head to Mars. And its goal is to gather up samples on the planet's surface, create these little caches, and then another mission will come along in a couple of years, grab those, and bring them back to Earth. Sorry, I had to rush through it a bit at the end there. It ran a bit longer than I was expecting, so sorry about that. But I've always thought that the history of how we've come is so far in just 60 years, from literally not even being able to get into space to being able to have regular missions towards Mars and the moon. It's really quite incredible. It's possibly not where people thought we would be when Sputnik first launched. You know, people thought we'd be holidaying on Mars, but that doesn't mean that this is any less spectacular. The fact that we've managed to send these robotic ambassadors out there and investigated the other worlds. So that is me. That is my brief history, a complete overview of robotic landers and rovers from beginning to end. And if you have any questions, are we doing a Q&A? I don't know, but if we are, please do.
Yeah.
Right.
Still
Okay.
plenty of time before. They're locked inside demo 2, but we've still got 40 minutes before.
Okay, right.
We haven't even started fueling up yet.
There we go. Now, oh God, no, I want to cancel the share screen. Okay. Are you seeing my face or are you seeing my screen at the moment? Good. That's what I wanted to do.
So there's a lot of, so from the Soviets in 1959 starting the littering with those lovely golf balls, or how big were those balls, sorry? Were they tiny, or do you know?
So it was one ball that I think was about, I think it's half a meter across.
Okay.
About that kind of thing, but it had lots and lots of these pennants which would then fly off as soon as it hit the surface.
Okay, so we've been littering lots of places.
Probably vaporized as soon as they struck the surface,
yeah.
But that wasn't what they told the American president when they handed him this big ball.
So going forward, though, let's go forward 50 years or so. Should we actually protect these sites, all these landers, all these rovers?
I think they should. All of the Apollo sites are World Heritage culture sites. You're not allowed to try and land anywhere near them. You're not allowed to, if when people do go back, you're not allowed to go and take souvenirs. That is now illegal. The question is, when do you stop, basically? Is every single landing site going to be classed as a cultural heritage site? Now that we've got so many more nations going, there's historical people, there's private enterprises launching their own landers to go to the moon that are trying in the next couple of years. Because also, if you say that they're all heritage sites, that means you can't pick up the rubbish. You have to leave them there. And that's a very quick way. Like we've already seen in Earth orbit, it doesn't take very long for space to get a lot more cluttered than you think it's going to.
Excellent. Any other questions? Oh, Jonathan. Oh, you're still muted.
I can't hear anyone.
That's fine.
Hello.
Just remind me of the infamous or famous Open University one that sadly was more famous for not succeeding in the end, but that got a lot of media attention.
Yeah, that was Beagle 2, which I didn't go into a lot of detail about because I had too much to cover as it was. But that was Colin Pillinger's baby. And it was a weird one because it wasn't really funded by the government or by the European Space Agency. It was basically Colin Pillinger going around trying to scrounge up money from whoever would be willing to pay him, and he managed to get together £50 million to build his lander, which he then bolted onto the bottom of, I think it was Mars Express, which was an orbiter that the European Space Agency was sending to Mars. And it managed to get to Mars, perfectly successful. It wasn't transmitting as it went down to the surface, because that's quite a complicated procedure, which meant they never found out what happened to it when it didn't phone home. But they found out several years later, NASA's, I think it was the NASA Mars Reconnaissance Orbiter, which was a big orbiter that went around taking really high resolution photos of the surface of Mars. And it actually found the landing site of Beagle 2, because it was a landing site, it wasn't a crash site. It actually managed to see that Beagle 2 had started unfolding. It had these sort of 5 circular petals that it was supposed to open up. And 4 of them had opened and the last one hadn't. And it was that last one that had the antenna to let them phone home on it. So that was particularly distressing when they found it out, is they were so close to landing on Mars and sending back information, but just didn't quite get there because probably one motor failed or something. But it did teach people a lesson. If you're going to another planet, put your antenna on the outside. Make sure it's the first thing that goes out.
Also a very good lesson in crowdfunding.
Yeah. It's never been revealed exactly who the funders were. I think some of it was government grants, some of it was individuals, some of it was businesses, and some of it was mysterious. So, yeah.
Thank you.
Oh, Charles?
I can't hear you.
Oh, yeah, right, okay, I'm back. My question is about how you can use the atmosphere of Mars to help you in terms of slowing down or moving around. And you talked about the various difficulties of landing craft on Mars. Atmosphere is very thin, about 1,000th of our atmosphere. Therefore, even a large parachute can't do it. But as I understand it, one of the new rovers plans to use some helicopter device to fly around. Now, if a helicopter can function, it's using the atmosphere to do it, which suggests that perhaps the atmosphere is more usable. So can you contrast those two factors?
It's It's very thin. I forget exactly what fraction of Earth's atmosphere.
1,000, isn't it? No, it's,
yeah, it's a lot.
Yeah.
It's a lot lower. It's less
Yeah.
than 1% of the atmosphere. And but one of the things Mars also is it's a lot less massive.
Sure.
Gravity's
Yeah.
a third less. So you need to generate a lot less lift to be able to lift the same mass on
1/3.
Mars.
Yeah.
But it's they call it a helicopter. It's more like a glorified drone. It's very stripped back about what it is, and it can't do huge amounts. I think its maneuverability isn't nearly as good as it would be in an Earth's atmosphere, but it is possible to build these kind of drone-like spacecraft which will be able to explore the surface. And they're hoping with these that they can begin to sort of bridge some of the gaps in understanding, because rovers, you have to send them somewhere where they can land safely, and then they can only go as far as they can go safely, and as far as they can go on their wheels. Whereas with something like a helicopter, you don't have to worry about where it's how it's getting there. It's as long as it's got like a vaguely flat place of rock to land on, it can go to a place that's filled with massive spikes, or a giant sand pit that a rover would get stuck in, and it can travel like 100 kilometers to get there, which would take a rover years and years and years. So it's exciting. I'm looking forward to see how this helicopter does, but we'll see. Hopefully it'll work.
Well, I get the point. For a helicopter, if you can have one, it's fantastic.
Yeah.
But it just seems to me, if there's enough atmosphere to make a helicopter of any kind viable, there is enough atmosphere to use a different purpose. And it's always struck me that the various other methods of landing, like retro rockets and so on, the crane, depends so much on so many things happening in the right way at the right time. Whereas a parachute, maybe a much bigger parachute, is inherently something that once the damn thing has deployed, it should be.
That's
really
actually the
viable.
problem. That's the problem with parachutes.
Deploying.
Is in order, like the bigger a parachute is, the longer it takes to deploy.
Right.
And there comes a certain size where it's just so big, it takes so long to deploy that by the time it's open, you've crashed.
Okay.
So that's one of the there's a whole bunch of different things you have to weigh up when you're trying to land on Mars. And whatever you do, everything seems to be exactly wrong.
Fine. Okay. Thank you.
What other questions have we got? Ooh. So we fascinated you enough. So how long do we have to wait for your book then, Ezzy?
That's due out. That's due out in October.
Will that be at all major bookshops?
I believe so. That's still a bit up in the air because it was supposed to be. Whether it still will be, we'll see. But yes, it should be.
Okay.
Don't worry, I'll be sending people emails when it comes out.
The book tour shall start. I was interested in your comment about people learning their lessons. But do you think the Rosalind Franklin has? Because Schiaparelli, that piled into the ground at several hundred meters per second, and they still they've got a lot more testing, but it was the nail in the coffin with coronavirus. They weren't going to make it, were they?
No, they were not. It was the thing that finally they said, like, no, this is silly, we need to postpone. And Mars missions do get postponed a lot. They do try to avoid it. They're very expensive. It's basically for every kind of, even if you only need to delay it for a week, you end up having to spend $100 million to store your spacecraft for the year 22 months until the next launch window comes around. But with Schiaparelli, they found what the problem was. I believe it was a software fault, which they have fixed. Whilst they were investigating that, they found a couple of other problems, which they have fixed. But the problem is with a Mars lander is there's no way to test it on Earth. You can test all of the individual bits, or at least run some kind of analog, but you can never test the whole thing together until you actually get to Mars. And so that's always the problem, is like they fixed this problem, which happened whilst they were still, I think it was like a couple of 100 kilometers up. What happens if there was a problem that happened whilst they were a kilometer up, but they didn't know because they already failed? It's definitely worrying ESA, that's the European Space Agency. They have been going over that thing with a fine-tooth comb to try and make sure that it lands on time and safely. Not on time, but to land safely.
Yeah.
And I think it, yeah, I was, as soon as they started having problems with the parachutes, like parachutes are hard to fix. That's why it's been delayed. They've discovered some problems with the parachute deployment mechanism. They thought they might have had a fix that didn't work. So now they're having to go a bit back to the drawing board to try and work it out. But now they've got another year, 2 years to work out those problems. So hopefully 2022, ESA will be back on their way to Mars.
Fingers crossed.
Yeah.
Excellent. Okay. Any final questions that people wanted to ask Ezzy before we break? And people that wanted to try and see if they could see the ISS at 9:20, or those that wanted to go and see NASA live to see the launch, fingers crossed. Any final questions? No? Well, thank you very much, Ezzy, for a very informative talk. You taught me lots, and no doubt you'll actually get at least one sale on your book. I'm sure you'll get thousands, but I'll certainly be looking to purchase it. Thank you for your time, and thank you for a very informative talk. Thank you.
Thank you for having me.
Thank you. Very, very interesting. Thank you.
Thank you. And I hope you guys, if you are going out and trying to observe tonight, I hope you have good luck. All right.
Fingers crossed.
All right.
All right.
Bye-bye.
Night, everyone.
Nice.
Bye.